Hi, in this video we are going to discuss about nucleophilicity versus basicity. This is quite confusing when we call it as a base and when we call it as a nucleophile, that we must able to differentiate between. But to understand this point completely, you must know its background or few more reactions. So before we start nucleophilicity and basicity, we will revise quickly what is nucleophilic substitution reactions, nucleophilic substitution reactions, and elimination reaction. Very quickly, elimination reaction. So if you know nucleophilic substitution reactions and elimination reactions, you can understand nucleophilicity and basicity more properly and its purpose also. So nucleophilic substitution reaction, what happens here in nucleophilic substitution reaction? There is a leaving group in the substrate, nucleophile is coming, leaving group leaves, and we get here substituted product. So this is product, this is nucleophile, and this is our substrate, sorry, this is leaving group. LG means leaving group, and this is a general platform of nucleophilic substitution reaction. So first of all, we are discussing nucleophilic substitution reaction. So there are actually two mechanisms. One is SN1 and another is SN2. I'll revise it very quickly. SN1 means nucleophilic substitution unimolecular, nucleophilic substitution bimolecular. So if the same substrate and same nucleophile undergoes SN1 or following SN1 path, then what will happen? So this is again two-step process. The mechanism is a two-step mechanism. First of all, carbocation is formed and leaving group is actually removed in the first step. This is a rate determining step. And in second step, this carbocation combine with nucleophile to get RNU. The problem is, I want to add little stereochemistry. So if this nucleophile is coming from the same side of the leaving group, then there is retention in configuration, retention of configuration, and if this nucleophile in second step is coming from opposite side, opposite means opposite to the leaving group, then this nucleophile will attach here, and in that case inversion in configuration takes place. So this is 50% chance and this is 50%. So 50%, I have added here stereochemistry. If this substrate following or the reaction conditions are actually directing that reaction toward SN1 reaction, then if the starting material is plus, then 50% plus and 50% minus will form. That is also called racemization. That means racemic mixture is formed. Racemization is the stereochemistry of SN1, either 50% retention in configuration or 50% inversion in configuration. What happened here? So nucleophile is always going from back side, that means opposite side of the leaving group, and simultaneously that nucleophile forming bond with the carbon and leaving group is actually going away. So we always get this product, and the stereochemistry is 100% inversion in configuration. So if starting material is plus or D, then this product is minus. So you have to remember only regarding the stereochemistry 2 points. One, if SN1 reaction, racemization, 50% retention, 50% inversion, and if SN2, 100% inversion. By knowing its the stereochemistry or the polarity of the polarization of the final product, by using polarimeter, we can find out whether SN2 path is followed or SN1 path is followed. This is about SN1 and SN2 reaction. Now I'll revise quickly elimination reactions. Elimination reaction, what happened in elimination reaction? We need this kind of substrate, proton at adjacent carbon and one leaving group. So this proton must be sufficiently acidic. So this proton is important and leaving group is important, but here we are using base. So what happens? This base will abstract this proton, this bond will move in between these two carbons and leaving group is going away. So we get here double bond in between these two carbons. So we are just discussing beta elimination in more detail. Leaving group and this base is abstracting hydrogen or proton. So acid base reaction is there. Now it can also following two paths, either E1 mechanism or E2 mechanism. One more mechanism is there, but we have to learn only E1 and E2 because that we have to compare with SN1, SN2 and all. So E1 means elimination unimolecular, elimination bimolecular. What happened here? Just like SN1, this substrate undergoes ionization, first leaving group, very similar to the SN1 reaction. Remember what I am telling, plus leaving group, and in second step only this proton is removed by the base, so it is very quick by the base, and then this bond is moving in between these two carbons to get carbon-carbon double bond. So we need not to discuss here its stereochemistry, that we'll learn, that we'll discuss in another video. But if it is E2 mechanism, what happened here? Again the same substrate following E2 mechanism, base is abstracted simultaneously and leaving group is also leaving in one step. So there is a formation of double bond, so BH and leaving group. This is single step. Everything is happening simultaneously, just like SN2 reaction. Now in SN2 and in nucleophilic substitution reaction and elimination reaction, if nucleophile is stronger, because substrate is same, if nucleophile is stronger, it will follow nucleophilic substitution reaction. Nucleophilic substitution. And if base is stronger, if the substrate is same, it will follow elimination reaction. So you can say this is a strong base and this is a strong nucleophile, you can say, or more nucleophilic, more basic. That term I think will be more appropriate. So you cannot say that nucleophilic substitution is 100% nucleophilic substitution or elimination is 100% elimination. There will be some product of nucleophilic substitution and there will be some product of elimination reaction depending upon the reaction conditions. The percentage of product will be more or less. So nucleophile and base is a very important concept which will tell us whether nucleophilic substitution taking place predominantly or elimination is taking predominantly. And that's why before we learn nucleophilicity versus basicity, we must know this background. Thank you.